Welcome to the lecture series in computer science on principles of deep learning. In today's session, we are going to focus on machine learning. So, moving on to the agenda of today's session, today we are going to give an introduction of machine learning. We will discuss about what a machine learning is and what are the different use cases of machine learning algorithms and what are its future scope of machine learning. So, before moving on to the exact definition of machine learning, here till now we have discussed in deep learning what is the meaning of deep learning, what are the different types of neurons and what is the role of activation functions. So, the next is to discuss on what exactly is deep learning and how to build a deep learning model. Before moving on to that, we wish to know about what is the machine learning different algorithms which helps in building the model. So, here to know exactly what a machine learning is, we should know about the data science, artificial intelligence and machine learning. See here, the data science is an interrelation between the two areas of AI and the mathematics. So, within the deep learning encompasses AI encompasses the machine learning encompasses the deep learning. So, together with the inclusion of mathematics, statistics and visualization and the AI, we come across this data science. So, moving on to the exact definition, the data science is the process of extracting meaningful and useful insights with a voluminous of data. And moving on to AI, we already know that artificial intelligence is a branch of CS, that is computer science, which helps or makes the machines to think and act like humans. And what exactly is machine learning? Is a subset of AI that uses the algorithms and the data for the machine to autonomously learn and improve with the time to provide the AI make decisions. So, here with respect to machine learning, we just make the system itself to think by using the various data and the algorithm. So, now what is the machine learning life cycle? How we have to build a machine learning model, what is the process that are involved in it, what are the different steps we have to be followed. So, here right from understanding of business and then moving on to data acquisition part and then deployment of information and then modeling the particular data source. Depending upon the data, we have to model it such that if something is test data is taken, depending upon the training data, we will achieve or we will predict the accuracy of the model. So, here to understand it, first we need to think of what are the data acquisition and understanding process. The data can be in varied forms, it can be from various data sources, it can be a database or it can be a cloud database, it can be a files like CSV file or a text file, and then you come across various pipelining of this data. It can be a batched data or it can be a streamlined data, and you think of an environment where the data accumulates or where the data is being generated. It can be on premises or on cloud database or on data lakes, or it can be a big data or a small data. And with respect to these data, there are many different cleaning process that takes place, whether it is structured data or unstructured data. We need to validate the data and clean up the data. So, all this wrangling, exploration, cleaning are all part of data acquisition process. And then we come across the modeling process, where you take into the consideration of feature engineering. You have to think of which are the important factors that makes the model to be more accurate, friendly in prediction, and you have to train the model. While you are training the model, see the feature engineering. If you come across the feature engineering, you will take either the textual information or the image information, and these features has to be selected out of 100 features or out of 50 features, which are the features which are more popular or prominent. Those kinds of features has to be first engineered, and then when you are taking the model training, you will apply various algorithms or you will fine tune the parameters such that you are making the model the more processing, or the more it gives the training, you give more training, the model will be more accurate. Then you have to evaluate our model. So, whatever the model is built, we need to evaluate the model whether it is correct with respect to what we expect or not. So, in doing so, we will do a cross validation or alpha beta testing. So, these all comes across with how we are building the model. And about the data deployment, whenever everything is ready, we need to deploy our data, and here we will always see the performance monitoring. So, you will use the model score, you will use some intelligent applications, you will use some web services, and in doing so you need to think of customer acceptance or not, and that gives the end of the phase. So, here when you take the machine learning life cycle, we need to first understand, we need to get the data, and data has to be undergone the various process of cleaning, and after the data is cleaning, you need to select the features. After feature is selected, we need to apply the model, and after applying various algorithms and accurately predicting the model, you will deploy the thing. So, this is about the machine learning life cycle. Now, here moving on, where and all these applications of machine learning lie? We come across deep learning, and we understood that deep learning is being applied in various domains across different applications we have gone through, mainly in case of the image processing. But now, when we see the machine learning things, the use cases are in across varied domains. So, if you take the healthcare sector, it is mainly used in drug discovery or predictive analytics or image analysis. So, these are the major areas where these ML algorithms have been applied. So, drug discovery, it is used to find out which drug will be more suitable for a kind of disease. So, when you train the information or the model, you can very well predict or discover new drugs. And here with respect to image analysis, we come across in healthcare, whenever we take any chest arrays or when we take the MRT scan, all this scanning of information with respect to any part of the human body all comes under the part of image analysis. So, if you take different some 10,000 X-rays and you want to predict whether a particular X-ray that was given is with respect to a positive or negative case, we will just use the image analysis. And here virtual assistant is a chatbot, whereby when you train by giving so many informations of data corpus into it, so whatever the question we are querying the chatbot, it gives us user friendly messages for us. So, this is one of the most important applications of NL. And genetics and genomics are the other things which are used in medical healthcare, where depending upon the input information that has been given, we come across the genetic information. So, these and all the various use cases. Data management is another one, where patient health data or the doctor's data is being safely securely stored, and whenever we require it, it gets triggered or it gets activated using the machine learning models. So, these are the various varied healthcare applications in case of the machine learning algorithms. And moving on to the finance sector, here finance, we think of financial information with respect to either the transactions that takes place by the from or by the customers, or we can take of the customer preferences. These are the two main areas where we concentrate. So, now coming over here, real time or predictive analytics of what are the shares or the sectors in case of the finance we can think, or we can think about the fraudulent transactions that is taking place with respect to the financial data. And something very important we come across is the customer support, customer segmentation and customer lifetime value prediction. So, these are different applications where whenever we buy something over online transactions, we keep on getting the same type of advertisements over to our mobile or email. So, these depends upon how once we are fascinated or interested in any one product, how it can be again offers have been come now, how we are getting those information is the usage of these machine learning algorithms. So, customer support, customer segmentation depending upon the interest, how the customers have been categorized, and then how you will predict whether a customer will be a valued customer for you for the lifetime or not, depending upon what factors we consider this particular prediction. So, these all is possible only with the help of the machine learning algorithms. So, the other applications are the customer data managing and the recommendation engines. So, these are the other applications when we come across the finance sector. Now, moving on to the machine learning paths, use cases with respect to the agriculture field is, we very well known that these days farming many technological advancements have come into place. So, when you first and foremost what we think is the predicting the weather condition. This is the foremost application in case of an agricultural domain. So, we can think that depending upon the previous history of 10 years data or 20 years data, we can say in that particular place whether rainfall will happen or not. So, weather conditions can be very well predicted using the machine learning algorithms, and digital soil mapping, managing the resources with AI, or detecting any of the leaf diseases or the plant diseases can be done. Automating the irrigation process with respect to any of the things, either water supply is being done with the irrigation using the power sensors, or you can think of the plant species, how to recognize with respect to the AI algorithms. So, these are the varied applications, and in all case drone, with the help of drone also we come across many different types of farmings can be easily done with respect to the agricultural domain. And moving on to the machine learning use cases in case of a manufacturing sector, the most important thing is the product design and the development. Many new products can be designed and developed using the systemized AI modeling or the machine learning algorithms, and even you can see whatever being the product that have been produced, it can be automated in the smart factory. And we have the other applications like inventory management and demand forecasting, where demand forecasting is very important in case of the manufacturing industry. So, if we give the past 5 years data or 10 years data into the system of a varied of 10 different kinds of products, and the system can give business level decisions to the managers saying that these are the products which are very popular or famous within the last 2 months, or this is the product which is very famous during this month, particular month, or in case of alternate years something is being very special among the customers. So, all these demand oriented forecasting can be done with respect to the machine learning algorithms. And the other important applications are the price optimization. You can very well predict the price values on a monthly basis or a daily basis with respect to the machine learning algorithm application, and preventive maintenance and fault prediction, supply chain optimization. These are the other applications. Here when you come across the fault prediction, it is very well understood and it is a very needed application using for the manufacturing industry, because anything with respect to any fault that can be predicted before itself, where you can improve your product production. So, that can be done very well, preventive maintenance as well as the fault prediction. This is a very popular area whereby in a manufacture sector this particular application is very important. And supply chain optimization, these various optimization algorithms can be applied such that this problems can be solved between the supply and the demand. Okay. So, moving on to the other domain called the transportation domain. These machine learning algorithms, we are using many of these applications in our day to day lives. So, when we see it's carpooling or car sharing application, this is already there, or the ride sharing, both nearly one and the same, where 2-wheelers, 3-wheelers etc. can be used for the ride sharing applications, and smart parking application, where in very big malls this smart parking application is already in place. Telecommuting, real time traffic management. So, we are using many navigation tools nowadays with respect to our mobile. So, whatever the navigation tool we are using here, the real time traffic is being captured and the system is giving us updates on, so with respect to the time factor, distance factor, real time traffic analysis. And with respect to road user charging points, connected vehicles, autonomous vehicles, bike sharing, or the personal assistant travel maps, or integrated fare management systems. These are the various applications that are already there, where these applications have been given as apps in the smartphones. So, all these applications we discussed, all these applications have inbuilt or at the back of the end many machine learning algorithms are in place. So, moving on to the next use case of machine learning is the climate change. So, where and all these can be applied with respect to a climate change, either you can think of a smart transportation system or that is sustainable, which is sustainable. So, biodiversity conservation applications are available, whereby these machine learning can control the pollutions. Okay, I am focusing on only the important applications over here or important use cases. If you see the healthy ocean, we see here again the habitat protection. We come across under ocean water, we have to think about how we will rescue the habitats over there. So, these are the different things, or there can be applications which will track the negative impacts of that particular acidification. So, when you got the water gets acidified, you can think, you can apply these machine learning algorithms and we can save or we can create a positive impact in the ocean water. And with respect to water security, we have the applications with respect to efficiency usage of water or the drought planning, how what we can do in case of a drought. So, with respect to clean air, we can think of the filtering and capturing process, or we can think of the early warning signs where the air gets polluted. So, these applications, they will take the air density across varied portions within a particular region, and the data can be historically 1 year data or 5 years data, and we can very well predict how in near future the air pollution gets impacted the human lives. And last one is the weather and disaster management. Here we can always see, or we can predict or forecast the disaster management, or we can think of any financial instruments in doing so. So, these are the various important applications with respect to the climate change. Now, we have discussed different use cases. Now, how the ML is been trending and how ML is been with respect to AI, how well the apps have been created. So, these are all the various advanced level applications apart from the previous use cases. So, you can think of a generative AI, or you can think of an augmented intelligence application, or we can think of something called no code tools, whereby all these no code, without any coding, we can have the applications being built, or we can think of various wearable devices, or we can think of the NLP applications. These are the various trending applications where MI algorithm plays an important role. And moving on to the other use cases, these are the varied applications that are already been there in process. We come across whatever we discussed till now in different domains come as a project or a use case with respect to the machine learning. We can think of a chatbot, or we can think of a weather prediction app. These all we have already been discussed, but with respect to the domain specific we have discussed. Now we are giving what else the students can focus when they are doing small capstone project. These are the varied projects that are popular now with respect to the ML algorithms. Okay. Or you can think of a traffic sign recognition project, or we can think of fake news detection, or we can think of some email classifying algorithms. Okay. Now, with respect to the other use cases, this we have already come across the credit card fraud detection, or we can think of whether a loan can be given to a person, that is loan prediction method or the algorithm, or you can think of some celebrity voice prediction. There are many sound recognition files or music playing files, whereby the system itself generates the automatic thing, or it can recognizes whose voice is that. So, these are the some of the applications we can think of the ML, or detecting whether a person will be affected with the Parkinson's diseases or not. And moving on to the other, as we discussed, we can check of the air pollution, or we can think of any handwritten digital recognition methods or models, or we can think of driver drowsiness. By sitting inside the car itself, we can very well say within few minutes whether by checking the eyelids of the driver or by checking the manual emotion of a driver, we can very well say driver has drunk or not with respect to the driver drowsiness. And there are varied applications with respect to the image caption generator. So, if you upload an image, it has to give a caption. So, these are the various other applications of ML. And here the most important, we can think of the sentiment analysis, or we can think of any of the healthcare related applications like breast cancer classifications, tweet classifications like Twitter classifications, that is sentiment analysis only with respect to the positive or negativity, or you can think of any movie recommendation systems. So, these are the varied applications of ML. So, till now we have discussed what is a machine learning and why this machine learning is very popular in predicting all these use cases. So, all these applications are utilizing many different algorithms. The most popular ones we will discuss in this session. Okay. So, moving on to the actual ML algorithms, till now we have discussed varied use cases. In all these use cases, these are the different algorithms that are behind the ML. So, algorithms are classified into supervised algorithms, unsupervised algorithms and reinforcement learning. So, with respect to supervised algorithms, we see that a linear regression, logistic regression, decision trees, random forest, support vector machines, k nearest neighbor, naive Bayes, k means, or these are the different algorithms, whereby under supervised learning, the meaning of supervised learning is you will have the control of input and the output. So, such type of algorithms we say as a supervised algorithm. So, the data will be very structured, and here all these algorithms takes the input data and they will use some 80-20 principle of 80% is the training data, 20% is the testing data, and when we give new labels or data sets, the system with a good accuracy prediction of 89% or 90% or above 90%, they will accurately predict the data set values and it will gives the topmost accuracy for the model. So, see here linear regression, this is the way where the input features and the target values, there will be a relationship and you are going to fit within that relationship. So, the well known use cases are predicting the house prices or the stock prices. When you take a logistic regression problem, here you will be using classification problems for this, and these are mainly used to classify the things, either the spam detection, whether the mail is a good one or a spam one, or you can say whether disease is being diagnosed or not. So, these types of problems can use the logistic regression algorithm. When you take the decision tree algorithms, this is mainly used for customer segmentation and the fraud detection. So, whenever your real world application needs that something has to be classified depending upon certain features, we will use the decision trees, and it is a tree like model. Okay. Then comes the random forest methodology or the algorithm, where here you can do various types of customer analytics and you can perform the medical diagnosis for this. And here also it is same as decision trees only, but here the in order to increase the prediction accuracy, this particular random forest aggregates the things. Okay. And support vector machine, it is mainly used for the image classification or the text classification models, and here what we do is here we find an hyperplane that best separates the classes in high dimensional spaces. Okay. And this can be used for both classification and the regression methodology. And moving on to the k nearest neighbor, the meaning itself gives that when we are traversing the nearest whichever point fully satisfies with the given criteria. So, the nearest of that will be all those data points will be taken into consideration. Here comes the example applications is the recommendation systems and the handwriting recognition methods. And moving on to the naive Bayes methodology, this actually assumes the independence between the features, and main applications are the text classification and the email filtering. Last one is the k-means algorithm. This algorithm is mainly used for the customer segmentation. So, these are the various popular algorithms with respect to the machine learning, and here we come across various pros and cons of all these methodologies. Okay. Moving on to the next method or the next type of algorithm called the unsupervised algorithms. We focus on k-means clustering, hierarchical clustering, DB scan, autoencoders and agglomerative clustering. And here if you see on which use cases these particular algorithms will be used, when you come across a customer segmentation or image compression, we can use this k-means clustering. Here the data will be partitioned into different clusters, that means different regions. So, whenever a incoming data fits into whichever regions, it will be just segmented. So, these applications, these clustering algorithms usually are very fast and they require only the sensitivity with respect to the initial centroids and the outliers. Moving on to the hierarchical clustering, it is also a tree type of approach which is either bottom up or the top down approach. Here it is mainly used for the social networking analysis. Okay. And then this DB scan method, it is mainly based on the density based clustering where weightage is being given. So, it is mainly applicable for spatial data or for the anomaly detection methodologies, whereby if a regular transaction going on, no problem. When there is a deviation from the regular one and you want to think of that particular when it gets deviated or how it gets deviated. So, this DB scan methodology or algorithm can be applied. So, all these algorithms depending upon our data set and our requirements, the algorithms can be applied. And moving on to the auto encoders, these are mainly important feature with respect to the neural networks, and here this is also being used for anomaly detection as well as the image denoising. That means, whenever the images get some of the noises have been added to the image and you want to remove those, in case you can use these auto encoders terminology. And agglomerative clustering, this is mainly used for the image type processing, and it is a hierarchical clustering approach that builds the cluster by merging the closest pairs. So, clusters have been built by merging the nearby points within that. So, this algorithm works within this particular feature. Now, moving on to what the actual we come across all these algorithms in a tabular format. The same is being represented for here for your convenience. If you take regression, it is used to predict the continuous data. If you take classification, it is used to classify the data into predefined classes. If you want to take a neural network algorithm, and it is mainly used with respect to the neurons in the different layers, and CNNs or the RNNs are the different factors within that. And moving on to the unsupervised algorithms, we discussed about the clustering algorithms or the dimensional reduction methodology or the anomaly detection methods. So, if you take clustering, it always groups the similar data points. That is the main thing we have to just think of. If you take the dimensionality reduction, it takes the number of features, but reduces and keeps retaining of the important features that are there for the data set. So, here this reduces the number of features in such a way that essential features have been maintained. And moving on to the anomaly detection methodology, it usually recognizes the unusual patterns in our data or the outliers in our data. So, here are the other final types of ML algorithm where there is semi supervised and reinforcement learning. We will focus only on reinforcement learning algorithm, whereby it is mainly used for training the agents to make a sequence of decisions. So, in deep Q networks or in proximal policy optimization or the features or the methodologies which use this reinforcement learning algorithm. This we will discuss little later after we are well versed with the CNN and the RNN architectural methods. Okay. Now, moving on to the NLP, we already seen NLP is a major application of deep learning. Here, when you consider with respect to text, not with respect to image, this word to vector and the glow, these are the two methodologies which use the natural language processing. So, sequence to sequence models takes the machine learning algorithms. In case of we know the well known applications are the chatbots for this. So, these ML algorithms, chatbots use these ML algorithms. So, till now we are discussing about what are the different popular algorithms of machine learning. Now, we will look into what are the different main tools that are there for the machine learning algorithms. These are the other algorithms which we will discuss little later, ensemble methods or the neighborhood based methods or the deep learning. This deep learning part we have been discussing throughout the sessions. Okay. Now, moving on to the other algorithms like recommendation systems, time series analysis, federated learning. These are the other popular algorithms apart from the supervised and unsupervised learning. These are the specific for one particular type of applications, these recommendation systems have been applied. So, now see, when we see these algorithms, this is mainly used for users in case of a collaborative filter or content based filtering. So, when your application stands for this, we will use this recommendation systems algorithms. When you use the time series data you to forecast something, then we will use this time series data. And federated learning is a privacy preserving approach whereby these machine learning models will come across the multiple decentralized servers, mainly privacy. So, when the data is being over the different servers and you are exchanging the raw data within them, then we see these federated learning methodology. Okay. So, federated learning is the algorithm which helps in privacy preserving approach, and when we see all the algorithms whatever we discussed till now is about applying to any of the real world problems. So, all these algorithms has its own pros and cons of applying to a particular data set or a real world problems. So, in next session we will discuss on the various machine learning tools that will be available on market to develop these applications.